And I know we got 30 minutes, so we'll try to move pretty quickly through this. Like I said before, you'll get the slides, you'll get the video. So if we miss something, uh, not the end of the world, we'll get to it. If you have questions, definitely drop them in the chat. With only like 28 minutes, we don't have a ton of time. Worked for a lot of different data companies. I have articles and source code at these locations. So if you want to just take a look at code, definitely check those out. I do a weekly newsletter, and I'll drop links to all the stuff. And when the video comes out, I'll make sure it's posted there so you'll be able to get right to that YouTube channel. Well, let's get into the content. Now, one of the interesting or difficult things today in when working with large language models is they don't just deal with traditional sources of data, like IoT data or table data, JSON, those sort of things. We certainly can use them, and I'll show you an example if we have time. But there's a whole new world of data, a very large amount of data that's in unusual formats. They are not structured like a table or a JSON document or Excel or CSV or Parquet. They are images, audio files, PDFs, Word documents, big text files, things coming out of Slack and Discord, all those things. Fortunately, we could take those, apply different deep learning models to them, and produce a vector format, which is just a large dimensional array of numbers, usually floating points, that can be used as a vector database. And why that's important is almost 90% of the data out there is in that format, and a lot of it is never used. So why waste all that knowledge? We could take it, apply the model, get our numbers, and once you have those numbers, you can get them back very quickly in a similarity search. And it's smarter than regular search. You're not just doing an exact match. If I put Apple, I will get back Apple in the context that makes sense. If I'm talking about Apple computer, I'm not going to get Apple to fruit. So that's very nice. Now, there is a lot of options out there for how am I going to take this data and convert it into a format that can be stored as vectors. And there are a lot of different models out there. Some of them are open source. Some of them are paid. Some of them have a free tier. Some of them go by APIs. Some are dense, which produce really large numbers from everything you push through there. It's like 15,000 dimension array, or they can be very sparse, like BM25, which is good for certain types of text, especially if you're looking for more, closer to an exact match. And there's some that could do both. So you have some options out there. Milvus is the leading open source vector database for most Gen AI projects. You could just pip install it, and I'll show you that in a laptop. But you could also run it in Docker, Kubernetes, in the cloud. Makes for a really nice open source project to work with. And what's cool is I work in my notebook pointing to a local database, change that to a server, change that to the cloud, and that's the only change I have to make is my connector. You don't have to change any of the other code, which is really nice to go from development in Jupyter right into a production environment. It's very cool. Now, one of the main things to do with LLM and vector databases together is to use something called RAG. RAG is retrieval augmented generation, which is a fancy way of saying grab some stuff and send it along to the LLM so it doesn't hallucinate or make up really bad decisions. And we can use Milvus or Redis or a ton of other databases to get that data and inject it. Today we'll do Milvus because it's really good for a vector search. So what we do is take some data, and this is the first part. I get whatever data that is. That could be text, PDF, And it could be traditional data. It could be things like sensors, and I'll show you how you could do that. You get the most important content out, chunk it into a size that makes sense for storage and retrieval. I don't want to put a 500-page book into one record. That's going to mess things up. There's a lot of options for this, and I've seen whole talks on how do you chunk and split data up into a good size for this. Lots of theories, lots of options. There's even models that will help you with the chunking. And then once we get it into the right size piece, then we'll embed it, store it in the vector database, and then it's made available. So I could just use this to do a regular search, and my search term gets turned into use an embedding model, turned into a vector, does my search, gets my data back. Now in RAG, I am going to take whatever prompt you had and embed that, get my results back, and use that to build a context to enhance your prompt, call the LLM and get you a response back. And fortunately, it's pretty easy. There are a lot of options. And depending on which piece you're talking about, how much you want it to do, I mean, a lot of these can be combined. Today, we'll do LangChain, which is probably the most common. It is pretty easy to work with. There's also a version for Java that I've worked with, which is kind of good. That when we do the extreme Java talk, we could talk about that. So that's nice. You learn LangChain and Python. You can use it elsewhere. PyTorch has some things you can do. Llama Index is probably the biggest competitor to LangChain. There's pros and cons to each one. I like both. We did LangChain first. Maybe next talk we'll do Llama Index. IBM has a really cool new open source one, data prep kit. Again, also Python. This one is nice, is because it does a lot of the cleanup and preparation steps and can run locally in Jupyter or get deployed to Spark or Ray or Kubeflow, which is really nice. If you're running in NVIDIA hardware, even on the edge, their microservices are really awesome. Good to check out. Haystacks out there. These five, there's a ton of other ones, but today we're doing LangChain. Again, we're going to do a very simple one. Again, getting this in the time. Now, we're going to use a llama, and which lets us run some models for free locally. Again, so I can run this whole app. All I need is Jupyter Notebook, Olama, and download a couple of libraries, and we're set to go. We're trying a couple different libraries. One of them is Llama. Milvus Lite is the one that runs in my notebook. LangChain we mentioned. Obviously, we're using Python and Jupyter, but you could also run in Google Colab. So this is Olama. It is open source and free for all the major platforms. Works really well, very easy to work with. Runs locally on your machine, or you can put it on a server somewhere. And it is really nice. It has a ton of different libraries. For this example, I'm using one from Meta. Everyone knows the different Llama ones. This one seems to be pretty good, and it's pretty small. You can interactively chat with a Llama on the command line if you wanted to, but we'll do this through a Jupyter Notebook. One thing that's nice is you can have multiple models there. And these are some of the models that I'm running. There's new models all the time. If you haven't downloaded the model you want, you could download it and work with it from the command line really easy. So we're going to pick one of these models and make sure we have all the libraries to work with. So within Python, we're going to need a couple of libraries. Now, these do change. I did see that some of them are changing for the next version. So I'm going to wait to see if that stays the same in the next release. And then we'll have to update some of the imports. Sometimes they move from community to their own group. It is an active library. You got to keep an eye on that. So we import all the things we need from LangChain, the Milvus connection, and I have a local directory where I put some of my PDFs. In the notebook that I give you, You can download those PDFs or your own. I'm downloading ones from my talks and from a couple of articles. So you could grab those if you want or use your own. It's up to you. And I've got a bunch more here. Whatever makes sense for you. So we're just gonna loop through all those documents, load them, get them prepared. We're gonna connect to Milvus. This is a local database, just running in local directory. Makes it very easy to create a collection. Collection is like a table. This is where we're gonna keep our RAG data. If it's not there, we can create it. I'm calling this the AIM stack. It's the easy, local, free open source RAG to do all the things you need to do. Again, pick a model to do your embedding. I like ones on Hugging Face because they're free, usually open source, and readily available. This one, the All Mini LM, pretty small, pretty fast, and pretty accurate for most English PDFs. Now, if you need support for multiple languages or charts or images or some other stuff, there is a lot of other models to pick, but this one is nice. So we picked our embedding model. We are going to chunk up those big documents. This is a decent sized chunk. Again, then we split it up and we're going to load all those splits together. Make sure they're loaded. And that's all you need. Now, I don't have a GPU. If you had a GPU, it'd run faster. Now, this one thing here, trust remote code. This is because Hugging Face is going to download some models for you. You need that depending on your environment. Again, if that doesn't work for you, you can use a different model. So we got our model. We are going to load from the vector store, pointing to those documents we just grabbed, the embeddings we ran on them, and the URL to connect to our local Milvus. This could also be replaced with a cloud or the local server or Docker. I don't want to get rid of the old data. You can, depending on, what you're doing, what kind of data you're loading, those sort of things. Now, this is the entire meat of the RAG app, which is pretty minimal. We import Ollama, so we have LangChain connecting to our Ollama. We are going to pick our model here. I've been playing with a bunch of different ones. There's different versions of Llama. There's, I tried some from Mistral. Again, there's a lot of different models on Ollama. Play around with them, pick ones that give you the results you like. Some are better for certain types of data. Llama 3.1 for some cases is better than Llama 3.2. Then we pull our RAG prompt, so it does all this for us. Again, I don't have to write a prompt. I don't have to combine the context from the vector database. This setup right here does the retrieval, grabs it from the vector store, and builds us a prompt. And then we just loop and keep asking questions. It is pretty easy. I'll walk you through some demos because even in only 30 minutes, we move pretty quick. I've got an example of how to do this with data on a Raspberry Pi with images at the edge. This one's kind of interesting because of the open source nature and some of these smaller models, we can run some right on the edge here and makes for interesting. Obviously, you have something like an NVIDIA, you can do even more. Here we're using the Raspberry Pi AI kit to be able to do some more advanced use cases. And one other example, maybe I'll peek into is using grabbing the live street camera feeds with all their metadata, getting them into a vector database and using that for RAG. But let's get into some demos while we still have some time here. Okay, let's see. This one is still running. Let's see if we got an example. And we'll do that. Okay. This takes a little while, but this is the code we were looking at just in a notebook. Now we have other ones that are a little more straightforward. This one is in, I have this already loaded for you. This is similar to the slides, but this has all the documentation. One thing I like to do is turn off the warnings. It's good to have them on when you're developing, but once you've done it enough, there's some warnings that there's nothing you could do about them. Some of them you can update your code, some of them you can get a new library. Sometimes there's nothing you can do with that. So what can you do? This is most of the libraries. I'm using a packaging tool called UV. UV lets you manage these things really nice, and it does a lot there. Okay, then like we mentioned, install Olama. Here we can actually run this from here. We can see which models I have. Mistral Nemo is pretty good. Lava is interesting for doing things like multimodal things with images. So there's a couple there. Again, there's that use of UV, makes it a clean way to do that. So we download, I mean, can't be any simpler than this, just a wget. Or we can write better code to do this. But this is a good way to be able to see what talks we've downloaded. We process them, connect to Milvus, like we mentioned, do our splitting, connect to Milvus. We'll double check that's still connected. Sometimes we lose our connection here with so much going on. Yeah, and we can see, we do a quick search to see what data we get back. Okay, that's good. And here is our query here. Again, pretty simple. It does most of the work for us. It gives us the prompt, connects to it, and then we run our questions and get our results back. Pretty straightforward. Now, how do you get data in there to begin with? There's a lot of options there. Depends on what you're doing. And one thing you could do is, hold on a second, something's acting weird. Okay. Is load the data. Now, this one is a pretty extensive load. This one is for street cameras. So part of the data is images. Again, one of the great things about a vector database and large language models, we can work with these unstructured data. And with this one, I've got a more advanced way to do my embedding. And this grabs my image, runs some PyTorch on it to get it normalized. And we're using ResNet 34 as our deep learning model to do that. Now let's get to the main code here. I'm also going to be running some YOLO models on those street camera images as part of the app. We connect to Milvus. I could have ran this in the local database like we did in Notebook, but I'm pointing to a local one I have in Docker that's on one of the other machines. Why that's nice is because then I can go to add to and look at the data while it's in there, which is nice to be able to see what's going on. Like for that one, that's the street cameras. Unless we timed out. Did we time out? Everyone wants to have security, so here we go. So we can browse through some of the data, and you can see there's a lot of metadata here about direction, URLs, description, location. I enrich it with weather, when we saw this happen, and some big text, but also two different vectors. One for that big text of the weather report and one on the image. And we could do a vector search in there and take a look at the results. And we can also explore that as interconnected items. There's a lot of things in this database, but you can see how we get all those back. We could also do that for things like ghosts. I have one that collects ghosts, and you can see the different data in there. Again, thousands of points, hard to image get a good image on all those. Maybe airplanes are a little less busy. We'll take a look. I don't see any questions yet. I know we have a few minutes, so I'm going to keep going through some of the demo. But if things look particularly interesting or there's something you want clarification on, let me know and we could take a look at that. There's different things based on what we're looking at and where they are. Yeah, like live planes is a cool one. I like that one. I'm collecting plane data from overhead and adding the sensors for things like, what's the name of the plane, what's the altitude, plus get things like a picture of the plane. And you can see here, this is what the plane looks like, where it is. Pretty cool way to be able to search that, browse that data based on different attributes, like different time zones. Like if you want to track your plane, you can say, oh, there's my plane. Oh, it's a 737. What other 737s are nearby? And go from there. Lots of different options. Pretty easy to do that. I know we got 8 minutes, so we got a little time here. Now, the nice thing about taking this unstructured data and putting it into a vector database, I could do that and use the automatic fields and it'll dynamically create it. Or I could add my own fields that allow for a lot of different metadata, like lat and long, here, name of a roadway. And then here you can see I have two vector fields in this collection. One is for the image and one is for the weather, which makes for nice source of data. So I'm grabbing the New York City weather, New York City cameras, grabbing some weather feeds at that same point, running YOLO against those things and getting it back. Pretty easy to do those things. What makes that fun is when we're doing that, I could use that data for RAG. So I could do things like ask questions about the cameras, the locations, what have you. Pretty straightforward, depending on what we're doing. And like I said, you can ask questions or just do searches. Like here I have air quality data. Did I connect? No, we can do our whole connection here. And then you can do a search on different data as it comes into the system, real time. Lots of different things you could do with the data. Let me see if I'm connected here. Yes, I am. So I could look at any of the records here based on location. I was looking for ones based on a certain name. We could return a lot of data if we wanted to, based on here where it's doing the location from. What's another interesting one? As you can see back how quickly that data comes back from all over the world here. And this one has PM2.5 values. That is a measure of air quality. Here we can show you can do more advanced ones where I could do group by. And again, speed wise, comes back is super fast. And we can match on things like, whole text that I'm going to match on a similarity search here, where it also limits it by location. So here we got the air quality reading at this wildlife area. Again, pretty straightforward, and all you have to do is connect it. We're in the last couple minutes. Is anyone have any questions? Otherwise, I'll wrap up these last couple of minutes. And I don't see any questions yet, so we'll just show you where you can get additional examples and source code so you can do your own work as you feel free. There's a couple other demos here, depending on where you want to run them. And the 101 stuff, if you haven't done any AI or RAG before, this is a good place to start. Tells you what you got to do to get your system ready. And that's it.